There was a time when this was the only way to make certain kinds of flat parts from sheet metal. And there was a time when this was all that was needed. But times and technology change. Parts had to be thinner and smaller and more precise in computers such as this and in hundreds of other mechanical and electronic applications. But more and more engineers had to abandon certain designs altogether. Because the needed parts simply could not be made. But no more. Now, the primary limitation is the creative imagination of the engineer. Given a wide range of appropriate metals, the engineer can design to a demanding degree of micro-dimension and accuracy. The reason is a new process for the manufacture of the complicated parts of the space age. Hamilton calls it photoforming. The advantages are impressive. No bird edges. No stressings from the pressure of stamping dies or holding jigs. Accuracy of the highest degree, and no deviation from part to part because of die wear. Limitless flexibility of design. Greatly reduced tool cost, from 1/5 to 1/10 the cost of conventional die making for such parts. This is true of prototype, limited run, or mass production. And greatly reduced lead time. With conventional dies, lead time for complicated parts averages 6 weeks, can run as high as 8 to 10 weeks. And for parts below a critical size, it is virtually impossible to machine a die. In photoforming, by Hamilton, average lead time is 2 weeks. And if there is urgent need, lead time can be further reduced. This, then, is photoforming, and this is how it is done. A drawing of the desired part is made with precise dimensions and coordinates provided in a separate schedule. The drawing is then reproduced on a translucent plastic sheet with a lamination of thin red film. The instrument employed uses coordinates to reproduce, not to copy, the drawing. The finished drawing is about 50 times the size of the finished part. Tolerances go to 1/10,000th of an inch. The first negative receives a microscopic inspection before it goes to the camera for the first print. The negative is then reduced in 2 steps to the actual size of the part. Where line thicknesses are more than 1/1000th of an inch, the Robertson camera uses ordinary film. For line thicknesses below that dimension, a high-resolution emulsion is used. The planes of the film and of the negative are exactly parallel. The first reduction produces a positive, check for accuracy. The final step produces the master negative, the photoforming equivalent of the conventional die. Step and repeat is done where indicated. Before the master meets the metal, the stock must be rolled to precise dimensions by one of Hamilton's complex of Senzimmer precision rolling mills. Generally, parts are made from 4 by 6 inch strip, but dimensions of 20 by 20 inches are possible. If special properties are needed, Hamilton has both atmospheric and vacuum heat treating furnaces for pre-fabrication treatment. The manufacturing process does not change the properties of the metal. The sheets are cleaned by brushing, etching, or chemical wash. Next, a photosensitive emulsion is applied, either by spraying or by dipping. Where a strip is 1/1000th of an inch thick or less, it is laminated to a plastic backing to facilitate handling. No adhesive is used. Heat and pressure bind stock and backing together. Rapid chilling separates the finished part from the backing easily and with no change in the part. Now, master and metal come together. A vacuum printing frame is used to assure thorough and intimate contact of master and metal. It is then exposed like an ordinary photograph, but using a special actinic light source. The exposed portion of the photoemulsion, marking the exact outline of the part, becomes impervious to the developer. In the developing tank, the exposed portion becomes hard and acid resistant. The strip now goes into the acid etching bath, either spray or dip. The acid dissolves the uncoated portion of the metal, leaving the coated part untouched and producing the part to exact shape and size. For the manufacture of flat parts from metal strip 2/100ths of an inch or less in thickness, photoforming is the ideal method. Tool costs in both time and money are about 1/10 those of conventional die stamping. Lead times are reduced. A prototype is not prohibitively expensive. A limited run is economic, and mass production does not add to tooling expense, because the master, unlike the die, never wears and never wears out. There are no burred edges. Extreme complexity of design is possible. Very small sizes are feasible. There are no stresses from die pressures or holding jigs. Consistent accuracy is assured. The 1/1500th part in a run is identical with the first. If it is a problem of small dimension in flat parts, Hamilton Photoforming can solve it at reasonable cost.
End of take.